Okay, thank you everyone so much for joining us today. We're really excited to be here talking about building saga patterns with Temporal. And I'm going to just give a few words introduction before we get started. So my name's Megan. I'm your host today. I'm on the product marketing team here at Temporal, and I'm joined by Steve, who's on our solutions architect team. So Steve, do you want to give a few words of intro?
Hey, yeah, thank you, Megan. I'm Steve. I'm a principal solution architect here at Temporal. Um, I'm based in Seattle, originally from Australia.
Awesome. Well, thanks for joining us today, Steve. We're excited to hear from you. So, a little bit more about what to expect from this session. So, we're going to start out with a brief intro to Saga patterns. Then, we're going to jump into some of the common challenges that people face when they're developing Saga patterns, how Temporal helps, and we're going to finish up with a section on how to implement Saga patterns in Temporal. And Steve has a great demo queued up for you all to dive into the weeds a little bit. So with that, I'm going to stop sharing. I'm going to pass the screen over to you, Steve, and let you take it from here.
Okay, thank you. Here we go. All right, Megan. You see the slides?
Yeah, we're all good.
Okay, perfect. All right. So what I want to do here is give a very brief intro to the Saga pattern, just to get everyone on the same page. So what I'm going to do here is, what is Saga? All right. It's a development pattern for business transactions. All right. It allows distributed system to ensure consistency. So the example I'm going to use throughout this talk is of an order management system, but it really could be any business or non-business transaction, any series of steps that you need to happen and succeed. And so the thing that's unique about Saga is even if these steps, this happy path here in the top half, the order service, the payment service, the inventory service, or the delivery service, even if these steps don't succeed or a particular steps fail, you want the system to end up consistent at the end. And the way that happens is through a series of compensations or rolling back steps in the flow or in the transaction. And so why Saga to achieve this? Well, it's a way of designing for success. So you're coding really for your happy path up above. You're coding for things to go right, but you want to make sure that any unrecoverable failures are compensated for. In other words, are taken care of. And the reason for that is you want your system to end up in a consistent state, regardless of whether these operations succeed or fail. All right. What I'm going to do next is let's look at a couple of common architectures for executing transactions across distributed systems, so kind of microservices setups, and why implementing sagas using these common architectures can be a challenge, right? And then the next thing I'm going to do is show you, give you a brief intro to Temporal, and then show you how sagas can be done in Temporal. All right, so the first architecture here is a choreography microservices architecture. And in a choreography architecture, each service decides the next step in the transaction. So for this example, there's a new order that comes in and the order service takes that. And the order service asks the payment service, hey, please process a payment for this order. The payment service is going to say, please reserve inventory for this paid order. It's going to ask the inventory service for that. The inventory service is going to complete that step, and then it's going to ask the delivery service, hey, please send this order out for delivery. Okay, so each service is contacting another service in turn. The benefits of choreography is that you kind of get this loose coupling. Each service really is only looking after what it takes, the requests it takes, and the subsequent action, right? It's only responsible for that. And so it's easy to maintain each individual service. And there's also no single point of failure. If one of these services go down, the other services are more or less unaffected, right? But there are inherent risks to choreography. So it's harder to create and update a choreograph service. So let's imagine we add a step between payment and inventory here, like an extra step in this order flow. Now you have to edit the payment service to request from a different service. You have to edit the inventory service potentially to accept a request from this new service sitting in the middle. And so it kind of inserts the need to create, to edit lots of different disparate services and make sure they succeed. And on that, on success, it's actually harder to monitor this kind of system because there's no one source of truth for state. Because each service is taking care of one particular task, there's no way for you to sort of ask, what is the state of this overall order? And have that given to you by a central place. And so it's harder to monitor and then also debug when things go wrong. Another risk here is that, let's say the delivery service is temporarily down. Your inventory service should really be retrying that. Like, let's assume it's just API downtime or something like that. Your inventory service should be retrying that request. Okay, and that means the inventory service needs retry functionality. But then, of course, every service needs this functionality. So what you end up doing is you end up building kind of sophisticated retry mechanisms into disparate services, which again is additional work. And that's another downside of choreography. How does Saga look in choreography? Well, just like the happy path where you had the order service contacting payment, payment contacting inventory, inventory contacting delivery, in a choreography-based Saga, each service decides on the next compensating step in a transaction. So to take the same example, delivery service fails. And let's say the delivery service fails unrecoverably. So we're not waiting for retries. Let's say the delivery service gave some kind of junk response back. Something is wrong, right? We can't proceed with the order. The delivery service needs to ask the inventory service, can you restock the inventory? All right, that's the first step in the compensation. The inventory service goes, can you refund the payment? It asks the payment service. And the payment service might say, can you revert the order? And then that may trigger an email to the customer saying, sorry, we couldn't process this. Something has gone deeply wrong, right? That's your Saga. So just like the happy path, where each service contacts the subsequent service, the compensation scenario or the rollback scenario goes back the other way. A downside to that is that the same risks apply. You can end up in such a strange state. So, for example, delivery service is down. Let's say the delivery service wants to restock the inventory. Says, okay, let's start rolling this back. Let's say the inventory service is temporarily down. Okay, and let's say we don't have retry mechanisms. Well, what's the state of the system? If I was to ask, what is the state of this order? Well, if I ask the delivery service thinks it's failed. The inventory service doesn't know anything. It's down. The payment service and the order service think it succeeded because it took an order and a payment succeeded at that point. So we end up with this kind of weird system state. And this is kind of what we're trying to avoid as developers and kind of operators of IT systems. The worst case scenario really is an inconsistent system state. All right, so moving on, and this is the final kind of development pattern or architecture I'll show, is orchestration. Okay, so this is an alternative to choreography. It's very popular, an orchestration architecture. And in this, you have a central orchestrator that controls the flow of transactions and compensations in the Saga case. So instead of each service contacting the subsequent service, we have this central orchestrator. And in this case, it's the order service orchestrator. And that order service orchestrator has the job of reaching out to each service, waiting for that to succeed, and then contacting the next service in turn. The great benefit of orchestration is that it's easier to code and maintain. Like, that's one of the main benefits here. Writing control logic in the one place to control the entire transaction is much easier than doing it in several places, like the choreography case. It's easier to debug and monitor, right? So the problem that we talked about with choreography, where what is the state of the system, is actually fairly easy to work out in orchestration. All you do is ask the order service orchestrator, hey, where is this order up to? Okay, are you up to inventory reservation? Are you up to sending delivery out? You have one place to kind of ask because there is a single central orchestrator. But you get additional risks with orchestration, or the way it's traditionally implemented. So scaling is often limited by orchestrator capacity. Okay, so now everything's going through the central service, and that means that central service has to be rock solid. It has to be reliable. It has to scale for sale periods in this order management case, right? This e-commerce kind of workflow. It has to survive Black Friday. And you also need to still code for retries. You're not going to get out of that. You need to make sure your orchestrator is equipped to cover for the case when a downstream service goes temporarily down. And you also, and the thing I haven't mentioned yet, and this is true of choreography as well, is you often have to deal with queues, eventing and message queues and that kind of thing. If you're looking for scalability, people start to implement queues, and that makes coding harder overall. It just makes it a little more abstract as well. And so that's an additional layer of complexity. And then when we're talking about order service orchestrator here, if I was to ask the state of the system, is that going to be in a database? Do we have a state database for that? Are we adding additional pieces here? And finally, this is the biggest risk of orchestration, to my mind. You've got a single point of failure. So if this order service orchestrator goes down, or a workflow has a bug, like one of the orders has a bug, um, how is that rescued? I mean, that may bring the entire system down. You may not be taking any orders. So with choreography, you had this kind of disparate scenario where a service isn't going to bring down the other services. In this orchestration case, if your orchestrator goes down, your business might stop. And sagas, the good news though about orchestration is that sagas are fairly simple. Just as laying out the happy path happens in one place in that orchestrator, laying out the saga case is also in a single place. In other words, if the delivery service fails in an orchestration scenario, the orchestrator is going to take care of that rollback or those compensations. It's going to say, can you restock the inventory? Can you refund the payment? And it's going to do it in a way where you have one place to know how that went. And so it's good from a system kind of consistency perspective. So given all that background, choreography, orchestration, sagas, I mean, how can temporal as a technology help? How can it help you code sagas in an easier way, like create sagas in an easier way? How can it help you do it more reliably and in a way that you get the insights you need to know that these transactions are succeeding? And so you get insights and the ability to debug if things do go wrong. So I'm going to spend a moment explaining how temporal works. Okay, so temporal is orchestration. It's a new kind of workflow orchestration tool. Temporal allows you to code reliable, scalable business transactions without having to worry about queues and events. It eliminates your requirement to add complex logic around retries. You get that for free. Or it allows you to avoid complexity around rollbacks or compensations or state, managing state machines. I like to think about, we have sort of an unofficial tagline. It's not an official tagline, but I always think about it, which is code like you're in college. You just have to think about, the happy path and then the rollbacks if things go wrong. You don't have to think about state machines. You don't have to think about state databases. You don't have to think about queues or events. Temporal abstracts all of that away, and I'll show you how in a second. And so you're going to get all the benefits of orchestration. You get a single place to code your control logic. You get a single place to monitor how that's going, right? Those transactions are going without any of the drawbacks. You don't lack scalability. You don't have this single point of failure issue. And I'll also explain how that works in a second. All right, so how does temporal work? Well, the first thing you do is you choose one of our SDKs, and there are many, and you create a workflow. A workflow is a central concept in temporal, and it defines your end-to-end process or control flow that you want to execute. On the right here, I have some pseudocode so it's no particular SDK or language, but I have pseudocode showing this order management use case. And a workflow for the order management use case, at least the happy path would look like process order and then run process payment, reserve inventory, deliver order. It's that simple. You just lay out the steps. Using the temporal SDK again, you compose activities that will be part of this workflow. And so activities are where your tasks are completed, and these activities can do anything you need. People often use activities to wrap API calls, for example. It doesn't have to be, but it's a very common case to have activities wrapping API calls to your services. Temporal activities have retry policies set for them, ensuring that they succeed when services temporarily go down. So that's a really big benefit of activities is that you do have these smart retry policies for when systems are temporarily down. And so you get that for free with Temporal. And so to kind of summarize the last couple of slides, workflow, control logic, activity, the steps you need to run. And again, that's my order example on the right. Once that workflow and those activities are sort of coded up, you deploy all of this in a temporal worker. This worker is going to run your application. It's going to capture the state of execution of those workflows. And the critical thing about a worker is that it runs in your environment and it requires like no change to how you build and deliver code. The only difference is you need to import a temporal SDK. And so these workers are really just lightweight processes that run your code on your data in your environment. And the really big piece about temporal here, and this is probably the most critical technical slide about temporal in this presentation, is that your workers that you've coded, running your application, running your workflows, they take direction from a temporal service for what to do next. The temporal service, including Temporal Cloud, which is our software as a service product, it captures the state of your application and it's going to deliver tasks to your workers or make them available for your workers to consume. The temporal service is where timers and retry policies and your application state is going to live. Okay, so it's this kind of this orchestrator. I like to think of the workers as constantly polling the temporal service, asking, what do I do next? What do I do next? So if you think of workers asking the temporal service, what do I do next en masse? That's kind of what temporal is doing. If your app is running in a worker and it crashes for any reason, or let's say the infrastructure that your worker is running on goes down, like the cloud infrastructure or the compute behind that worker, another worker can actually pick up that exact work, and resume execution of a workflow without you doing anything. And the way that happens is that worker is going to ask the temporal service, hey, what was that? Where were we up to in that workflow? And just continue carrying out that workflow like nothing ever went wrong. And this is a massive value proposition of temporal. It means that workflows are durable beyond any individual process executing it. So it can survive any worker crashing, any worker dying, any infrastructure under it going down. That's true of your workers. And also the temporal service, including Temporal Cloud, are both designed to be horizontally scalable and fault tolerant. There's also a Temporal Cloud, which is our pay-as-you-go kind of product. Our SaaS product has a feature called multi-region namespaces as well. And that means your workflows can actually survive an entire region going down and pick up like an entire cloud region. And those workflows will pick up where they left off. So again, another massive bonus, but you can do that of temporal service as well. The self-managed temporal server. How temporal helps sort of insight and debugging. Final slide about the temporal prop is we have an event history. So temporal runs everything the workflow does is recorded in this event history, and that enables easy insights for you to know what's going on. It enables debugging. Like you're going to get debug level, stack trace level information about every step of that workflow and how it went. And this allows you to really trace the entire execution path. So there's no more like correlation tokens. There's no more log diving. It's all there in the temporal history in a way that's just very, very easy to interpret. The last thing I'll say about temporal is it's all MIT open source. That goes for the temporal service and the SDKs. So this is just a straight up open source project that you can run. All right, so with all that temporal background, I'm going to show you implementing Sagas with temporal. I'm going to show how it's easy. I'm going to show you how it's resilient. And I'll also show you a little demo that I did in the Java SDK. All right, so back to our order fulfillment workflow. We've now organized this order fulfillment into temporal. And so what you see here is we have this temporal workflow. So we're taking an order and that actually kicks off a temporal workflow. So you can think of one order, one workflow. And now each step is an activity. And so the first activity is going to ask the payment service to process a payment, so on and so forth. As you recall, activities have retry policies as well. So this workflow can now survive temporary downtime in the payment, inventory, or delivery service and pick up where they left off. Onto how a Saga pattern looks in Temporal, and I'll show you the code level in a second, but on an architecture kind of level, you the state is persisted. You have okay, so the Saga is it's straight up orchestration. The Saga case really looks the same as the orchestrator case I showed you before. But the benefits of Temporal is you get the state persistent in an event history. So instead of this single point of failure problem, this workflow can persist beyond the worker that's executing it. To put that another way, if there's an issue with the temporal workflow on the worker dies, the worker crashes, the infrastructure goes down, this workflow will survive. Another worker will pick up that workflow and carry it out. And so it kind of gives you all the benefits of that orchestration without the kind of single point of failure problem of orchestration. But for the Saga point itself, it's going to look the same as the orchestration case, because what you're doing is you're catching something that went wrong. In this case, in this diagram, it's the delivery service that's failed again, and you're essentially carrying out those compensations after that delivery service fails. All right, into code a little bit. So here's a snippet of a temporal workflow that implements a Saga pattern. And I've done this in the simplest way I could think of, which is a try and a catch. And so we're up to step 3 here, and our delivery service has been failing a lot in this presentation. And so I've shown you step 3, and which is delivering order. And so this is literally temporal workflow code in Java SDK. And so if you try activities deliver order, let's say that fails unrecoverably, then we can catch that exception that comes out of it, and we can carry out those compensating actions. So anyone who knows development will recognize a try catch, and will recognize that once this unrecoverable error has been caught, that those compensations are running. And those compensations are running in reverse order, by the way. You get cancel delivery, restock inventory, refund payment. And by the way, these can be done in parallel using temporal. That's fine, but I'm choosing to do them sequentially to make sure each goes fine. And then finally, what we're doing is we're wrapping the workflow in an exception, in that exception. So we capture the information of what went wrong with the deliver order step, and then we're going to fail the workflow. And so this will end up with the workflow failed. Again, this is for the unrecoverable case. If the order delivery was temporarily down, what the retry policy would kick in. But this is the case where there was something catastrophically went wrong with the order delivery. There was a bug, there was an invalid response that came back, and the workflow just doesn't know how to recover. We're just going to roll back these steps. So that's the simplest case. But the Temporal's Java SDK actually contains a Saga helper class. And this allows you to create these compensations with less code in that control logic. And for the other SDKs, we have a Go SDK, .NET, TypeScript, so on and so forth. You can quite easily create a Saga class. What this Saga class is doing is really just collecting a list of functions it'll need to run in case of failure. So it collects that list of compensations it's going to need to run. And so if we reorganize our code into this to use this Saga helper class in Java, what you end up with is you have the compensation step that you add first. And then in this case, it's step 3 again. So the compensation we're adding is cancel delivery if the delivery fails, right? And then we try deliver order. And let's assume that deliver order fails again. Delivery service is really bad today. We catch that exception in the same way we did in the last slide. But we run compensate, and all compensate does is iterate through a list of compensations in reverse order. So the last compensation we added, it's going to execute that first. And so in this case, it's going to run the compensation for cancel delivery, and it's going to run the compensations for restocking the inventory, refunding the payment, so on and so forth. But this is just a simpler one-line way to do it. And then finally, again, because this is an unrecoverable situation, we are going to fail the workflow. Last code slide. To put it all together, I just wanted to show you the complete control logic for a temporal workflow that includes a Saga pattern. You'll notice it's small enough, like this whole use case is small enough that I can fit the entire control logic on a single slide pretty comfortably. I'm not going to spend too much time on this slide at all because I'm actually going to run this control logic. I created this and pasted it in IntelliJ and ran it, and it worked. So I'm just going to run a quick demo where I'll show you a Saga in Temporal and show you how that looks in the temporal UI. Okay, demo time. All right, so you should recognize this because this is literally the code that was on the slide. I think I have an extra logging statement here, but aside from that, it's exactly what you saw on the slide. You have our compensations and you have an order. So this is a workflow here, this workflow method. And then we have 3 activities: process payment, reserve inventory, deliver order, with their corresponding compensations that we're just going to add in case any of these steps go wrong. And so what I'm going to do first is I'm going to run the workflow. And I do that just by calling a caller that I've set up. It's just a method that calls the Temporal API. I'm doing this in Temporal Cloud, which is our SaaS product. But you could do this on the self-managed sort of open source Temporal. Okay, so this workflow is running. And if I click on it, it's actually not going to go anywhere. I wanted to show you this. There are no workers running, actually consuming tasks. So like I said, workers are something that you run in your infrastructure that executes your code. Temporal Cloud doesn't know anything about the code you need to run. It just knows that there's a workflow that needs running. So the first thing I really need to do is start a worker that's going to run this code. So let me do that and then go back to that interface and I'll show you it running. So we go back to IntelliJ. I'm just going to start a single worker. All right, we go back to cloud. If I refresh this, these tasks should be coming in. Okay, process payment, it has started. This is all marked out. You'll see that in a second. Reserve inventory is happening. Deliver order is happening. And that should finish soon. Great. And if I go back up here, you can see that the order is completed. This is a successful workflow execution. It's just the happy path to begin with. The workflow is complete, which is an order processing example. If I look at my workflow execution, you're going to see this kind of dead time originally because I wasn't running a worker. We started the workflow here. There were no workers to consume it. And now we have these 3 steps that ran once I started the worker. Okay. So these 3 steps. And this, again, for a Saga webinar, this isn't a very exciting demo. I'm going to start messing things up in a second and show you those Sagas kicking in. But those are the 3 happy path steps. And so that's why the workflow completed without a problem. So the next thing I'm going to do is I'm going to go into one of these activities: process payment, reserve inventory, or deliver order. And I'm actually going to make one of them fail in an unrecoverable way. And that should trigger the Saga compensation. And so maybe the most interesting thing to do would be to make deliver order, that activity, fail, because if I make this like the final step of the order fail, it's going to have to go back and roll everything else back. So let's do that. So going over to my activities class, where my activities live, you'll immediately see that it's all just mocked out code. I'm just putting like thread sleeps in and logs in. Like we're not doing any real API calls or anything. But if I go into deliver order, I'm just going to make this activity fail. And the way I'm going to do that is I'm going to throw a runtime exception. So this is just a classic Java runtime exception. There's nothing special about it. I'm just essentially making this method, this deliver order activity, crash. And like I said before, if I made it crash, the default thing for Temporal to do is for the retry policies to kick in. Temporal wants workflows to succeed. And if there are temporary errors, or if there are errors, Temporal is going to assume they're temporary, like API is being down or some other issue that will right itself. But in this case, we want an unrecoverable failure because we want to trigger the Saga. So what I'm going to do is I'm going to put that runtime exception in a temporal concept here, which is a new non-retriable failure. I'm going to feed this to that. And that basically tells Temporal, hey, this particular exception that came through, we can't recover from this. Something is deeply wrong with the delivery system. We're just going to need to fail this workflow. We're probably going to need to go back to the customer and say, hey, that order you put in, just sorry, we can't do it. Like, it's a really unhappy case, but let's do it. So that's in now. I'm going to save that. I'm going to restart my worker with that new code. So kill the old worker. Run the worker again. So that loads this new version of the code. It's ready to go. And I'm going to run that workflow again. And so this time it's going to run the workflow and it's going to get to this deliver order step and it's going to encounter that runtime exception. and it's going to throw sort of an unretriable failure. And that's going to trigger these compensations. So let's do that. All right. Things happen quickly. So I need to go back to the interface. Wait a second. There it is. All right. It's processing the payment. It's reserving the inventory, or at least it's trying to reserve inventory. That should succeed. And then now it's trying to deliver the order. Okay. That's our runtime exception right there. Delivery failed, which is my little runtime exception message. And you can see immediately now that deliver order has failed, those compensations have kicked in. Cancel delivery, restock inventory, refund payment. And so just like that, you get that Saga pattern. You get that those rollbacks or compensations. And to put that into the timeline view, Temporal's kind of timeline view here, we now have a workflow and it's big and angry and red because it failed. If I go up here, it says it failed too, right? Because again, this is unrecoverable. We process the payment fine. We reserve the inventory fine. Deliver order had that nasty runtime exception in it that you can't recover from. And because of that, the workflow triggered Saga compensate. And Saga compensate canceled delivery, restocked the inventory, refunded the payment. So it rolled back each of these steps. So this inventory has now been restocked. This payment has now been refunded. The workflow has failed. Of course, you could have a step here that says notify customer of the failure. But that's all I wanted to show you in sort of the temporal demo. I just wanted to show you how lightweight and simple something as complex as a Saga pattern can be if you use temporal. It's all plain old code. If you're a Java developer particularly, this is going to look very idiomatic to you, hopefully. But we have SDKs in tons of languages as well. But that's the end of that demo. I have one more slide just to kind of wrap it up. All right, so I was thinking about what is it like to code sagas when you use choreography or when you use kind of traditional, what I consider traditional orchestration technologies, queues, state machines, state databases, that kind of thing, versus temporal. And so when it comes to coding, choreography is instantly difficult when you're trying to do sagas because Saga code is going to be all over the place. Orchestration makes life better because you have a single place for that Saga code, and all those rollbacks are in a single, all your control logic is in a single place. But scaling really, and developers will know this, doing orchestration in a scalable way and in a fault tolerant way these days requires you to think about message queues, buses, state databases, state machines, that kind of thing. And so life gets very complex as a developer. Whereas temporal, you've got this, you saw it just then, you just have this single place for Saga code, no dealing with queues. Of course, queues and databases are happening in the backend. Like that stuff, we have that stuff, but you don't have to think about it. For the scaling side, a traditional orchestrator can have scaling challenges, right? All orders are going through or being orchestrated, and all state is being captured by this orchestrator. But temporal is horizontally scalable out of the box. I could have run 1,000 workers and then just started throwing that order demo, like tons of orders at my demo, and temporal would have handled it just fine. The same is true for the temporal service. So the temporal service is architected to be horizontally scalable and fault tolerant as well in many ways, particularly our temporal cloud, our SaaS product. We've done a bunch of work around making that resilient, fault tolerant. For debugging and insight, troubleshooting choreography, it's difficult. Problems in a service, you have to really debug that service, so you have to use correlation tokens and log dive to know what's going on. I'd say with orchestration, it's easy. You probably do have to have a state database or something that persists beyond a process running to understand what's going on. But in temporal, you get the luxury of this event history. You get this temporal runs on this event history in that UI, which you can also access by command line, or you can access by API. So you don't have to use the API to know what's going the UI to know what's going on. There's very different ways to see the event history. You can go there though to know what is the state of that order, what happened in that order in great detail. You saw that when I made the delivery service fail, that it said delivery failed. But if I was to click on that, there's literally a Java stack trace in there that you can look at. So you get extreme insight, I would say, on a per workflow or per transaction level. So kind of to wrap it up, hopefully that gives a good overview of the challenges people usually face implementing sagas. And I was able to show you what that looks like in Temporal, and that it's just, I just think it's a lot easier. And so if you're coding sagas and you're coding complex business transactions, I think you should consider Temporal as a simpler, more reliable option. And with that, happy to take a ton of questions about Temporal, whether it be sagas or anything Temporal related.
Awesome, Steve. Thank you so much. So we did have a lot of questions come in. We'll try to get to them all. If we don't get to them all, we can follow up over email. So don't worry about that. You'll get your question answered one way or another. So just to start out, there was a question, will this recording be available? Yes, it will be. We'll be sending this out for everyone to watch afterwards. I'm going to just pull out a few of the common themes of some of the questions to get to them, and then let's dive into specific questions. So there were a few questions about the SDKs that are available. And so do you want to just talk a little bit about that?
Yeah, definitely. This is going to be a test of my memory. The SDKs that we have are Java, Go. They were the first two SDKs, by the way. TypeScript, Python, .NET, and I believe that's it for now. And the thing about our SDKs is that you can do the same temporal things in all of them. So the feature wise, they should be very, very similar, like almost a complete parity, if not complete parity. For temporal, what you can do temporal wise. But the most important thing about the SDKs to me is that they're idiomatic. So if you're a Go developer, you're going to be dealing with Go routines and channels. If you're using TypeScript, you're going to deal with a wait. You do promises, so on and so forth. And so that's what I like about it. .NET, you're going to use tasks. It's very idiomatic. It's very comfortable for developers who know those particular languages.
All right, awesome. Thank you. Okay, so I'm going to go and we can start addressing some of the individual questions here. So Alec wants to know if a single workflow can have activities that run on different microservices.
Whether a single workflow can have activities that run on different microservices. Yeah, definitely. You can, if I have your question right, you can split out your activities to run on different infrastructure. For example, so let's say you had, and the way you do that is you can have your worker talk to different queues. So let's say you have one workflow, and you have a worker that essentially just polls that workflow for the next thing to do. Any of those activities can actually run on different workers in different infrastructure. A common case I think about, or a case that's becoming increasingly more common, is an AI type use case where you'll have this data processing step maybe that runs on standard CPU based workers. So those activities will run on compute infrastructure that's sort of plain old. And then you'll have like a GPU inference step, and that inference needs to happen on a big fat GPU machine. And so what you're going to use is you're going to have workers that run purely to execute that activity on that machine, but it's within the context of that entire workflow. So what you end up with is this workflow that essentially executes across a disparate set of machines, but in a way where it's all durable and you have a single event history, all that good temporal stuff, but it's definitely optimized to run in many different places.
All right, thank you. Dave wants to know if an activity is the same thing as a virtual actor.
Um, to be completely honest, I would have to know more about what a virtual actor is. So maybe we can have a follow-up conversation. A virtual actor to me can mean a couple of different things. So rather than deep diving it here, let's have a follow-up conversation. I would say an activity is it really is a wrapper to a set of arbitrary code. So what happens in an activity is completely up to you. It could be processing data, it could be running AI inference, it could be making API calls. Temporal doesn't care at all what happens inside activities. What we do care about is that we wrap them in a way that we can schedule them and we can retry them and we can collect an event history on them so they become durable. They durably run. And I think maybe that does correspond to a virtual actor when I think about it, but it's definitely worth a follow-up conversation.
Awesome. Okay, so we kind of covered this in the presentation, but someone wants to know, can Temporal handle backward recovery across multiple services? And then do separate teams need to share code in order to compensate across application boundaries?
It's a two great questions. The first answer is yes, you can essentially compensate over like multiple disparate services for sure. And I hope I showed that. Just assume those activities are making API calls to disparate services owned by different teams in my demo. Um, as far as multiple teams working on workflows and that kind of thing, I think the great news for Temporal is normal code collaboration and organization constructs apply. So just how you would, in the same way that you would organize different code into different repositories and run them in different environments, right? And collaborate on them in different ways, and also run them in different environments when you're operating them. You can do the exact same with Temporal. Because Temporal is just code, you can slice and dice workflows and have parts owned by different teams. You can have activities that are owned by different teams, and you just import them as libraries or however you want. I would say think about from that perspective. Think about this not in really temporal terms, but think about what would you usually do in code to organize your concerns, right? How would you organize those transactions across multiple teams? And the same should apply to temporal, because at the end of the day, you're just using the temporal SDK. You should be able to organize things the way you usually do.
Great, thank you. So Bradley's wondering about, he's saying the big drawback for orchestration is that the orchestrator goes down. Wouldn't relying on temporal suffer from the same issue? You know, you addressed this a little bit, but maybe you can get a little bit more into the temporal service.
Yeah, I'm glad you asked that question. And I was hoping someone would ask that question. Let me go just a little bit. I know we're getting probably to time, but let me go just a little bit into.
Sorry, we can go over. We can go over a
Oh,
10.
okay, cool.
So people have to jump, they can jump, but we have a lot of great questions. So we'll give it a few more minutes past the top of that. All right.
Awesome. I think this question deserves like a proper answer. Yeah, the temporal service, because the workers are taking tasks from the temporal service, um, it is a single point, right? It is a single point, but I would say that it's a much more fault tolerant single point than any other orchestrator that I know. So, for example, the temporal service um, is architected in an extremely horizontally scalable way. It's a series of services. People often run it in Kubernetes, but they don't have to. Temporal Cloud runs in a certain way. That's our SaaS product, where it stretches across availability zones. There are multiple redundancies, including on the database level. And so, for example, I'll talk about Temporal Cloud because that's what I know quite well. It can survive an entire availability zone loss in an AWS cloud region, and without any downtime, without any data loss, right? Zero. And that's a testament to the resiliency of the temporal service. So the next question you might ask, and I kind of talked about this in one of the slides, is okay, well, what if a whole region goes down? And I say, okay, good point. That is generally a catastrophic thing. My question for you my answer for you is twofold. The first thing is, if an entire region goes down, you probably have more problems than just temporal. I would say, frankly, and in my experience, that tends to be true. Think about all the services you have, but let's say you have a truly multi-region redundant setup, which is true, and people should strive for that. We do have a feature of Temporal Cloud called multi-region namespaces, and there is an upcoming webinar about this actually, so that's probably good timing. Where Temporal has asynchronous replication on a very tight timeline, where it can tolerate an entire region going down and seamlessly switch over to another region to complete those workflows with very, very minimal disruption. And that there is your resiliency case, I would say. That is your way around your ultimate way around a single point of failure for applications that are extreme mission critical.
Perfect. Thank you.
Cool.
And we also touched on this very briefly at the end, but Michaela has a question about how does temporal scale?
Yeah, great question. There's two kind of aspects to that. There's the worker side, and I think that's easy to understand for a lot of developers. The more workers that you add, to consume workflows, the more scalable it's going to be. So I'll probably end that one there. And then the other question is how does the temporal service itself scale? If you're self-managing temporal, that's going to be on the strength of the amount of compute you add to it. Like I said, it's a horizontally scalable service. So you can actually add database capacity. You can add more, if it's a Kubernetes setup, you can add more history pods, matching pods, front end pods, like our kind of the services that can compose the temporal cluster or the temporal services. You can add them on the fly. And so that's how you kind of get your scalability out of the box. And you'd have to monitor that yourself and then respond or set up auto scaling policies for those services. In Temporal Cloud, we run it as we run that kind of scaling transparent to you. So in other words, we give you a namespace, you connect to that namespace, and we run it in an elastic way behind the scenes. So instead of thinking about Temporal Cloud as a single server that we run for you, what we're really doing is running a set of servers that we interchange constantly. We do a very elastic thing behind the scenes to make sure that if you get a spike, we can respond to that spike extremely quickly. In fact, people who have been running workflows in Temporal Cloud en masse may not know this, but we're actually constantly changing infrastructure around, upgrading things, doing all kinds of stuff with zero interruption to your running workflows because that's how it's been architected. So I think scaling is different depending on whether you're self-managing or whether you're using our cloud product, which is a bit more sophisticated in that scaling way. But either way, we're set up for it.
All right, thank you. Dave had a question about this is one that's a little bit complex. Can an activity inside a workflow within a worker initiate a child workflow within another worker? Maybe we'll just follow up with this one because there's a lot.
I love that one in writing. I'd hate to get the
Yeah,
I'm sure it's in writing in the chat, but I'd love to think about it in deeper. I don't want to give an answer that's wrong because I misunderstood the question. From what I heard, I think the answer is yes, but let's just talk about the implications of what you're asking. That's definitely a follow up.
yeah. Okay. And then we do have a question about some alternatives compared to temporal. So is there anything you can talk about the differences or advantages of temporal over something like MuleSoft?
Yeah, I don't want to talk about specific kind of alternatives or anything like that. That may feel mean or wrong, but I'm going to say there's a couple of categories of alternatives. One would be like a BPMN sort of visual workflow builder type solution, and people tend to like them because you can see what you're building. You can structure your workflow in a very visual way. I think the drawback to that is you're not running that diagram directly. There's always going to be some translation between what you're putting together visually and what actually runs. And so, from a debugging and complexity standpoint, firstly, you're probably not going to be able to capture the true complexity of what you want to do for any workflow that's reasonably complex. And secondly, I don't feel too comfortable about sort of putting something together in a diagram and knowing that's exactly what's going to run. I feel much better about Temporal because I can unit test it, I can integration test it, I can throw test workflow histories at it or past workflow histories at it to know that if that succeeds, then the production case is definitely going to succeed. So that's one category, sort of your visual workflow designers. And the second category I can think about is sort of your DSLs or your kind of JSON, usually JSON or YAML based kind of specs. Like there's a lot of workflowing solutions out there that really translate to a bunch of JSON, like a DAG or like a graph, a task graph, or a YAML kind of structure for this is the stuff that needs to run. And I've actually had quite a bit of experience in some of those. And again, it's the same reason. It's just not very comfortable. It's not very, as a coder, I want to write code and I want to read code. I don't want to read JSON. I don't want to debug JSON. I don't want to, I can't, like unit testing JSON is kind of annoying. You have to sort of pull it in and then pass it. And like, it's just very uncomfortable. The reason why I like Temporal and join Temporal is it allows me to deal with code as code. And sort of as a past engineer, that's just way more comfortable. So I think that's, yeah, BPMN, visual workflow designers, and then sort of your transpiling cases or your DSL or your JSON YAML type cases are sort of our main the main alternatives, I would say. But I think for developers, they tend to prefer Temporal, and that's what we're seeing. They tend to prefer workflows as code, and that's what we're seeing.
Yep, exactly. So we'll take just maybe two or three more questions, and then we'll wrap things up and follow up afterwards with the rest of the questions.
Awesome.
Okay, so William had a question about he's wondering in the order example, can the workflow run asynchronously? I.e., when a new order request comes in, does the caller have to wait for all the activities to finish before a response can be sent back?
No, not at all. Temporal is insanely asynchronous friendly, I would say. So there's multiple levels. For the demo I gave you, I could have started 1,000 orders at the same time, and that single worker could have just processed through those pretty gracefully. Sure, that worker would be busy if that was 1,000, but the great news is because there's an event history that presents the next task to do, even if that one worker was overloaded, and even if I didn't want to scale it, that all that worker is going to do is say, "Hey, I'm not ready for this yet," and the temporal service is going to sit there with the next task ready to go. So in other words, it might get slower to execute, but if you don't scale it, but you can absolutely throw a bunch of orders at it async while it's busy, and temporal service is going to make sure all of that succeeds. The other case is, and you didn't exactly ask this, but I wanted to mention it. Asynchronous code is ridiculously easy to write in temporal because you don't have to think about queues and state machines and databases. You can just write async code as you would in a single script, using promises or awaits or tasks or go routines or whatever you're used to. And you can also interact with workflows while they're running. So let's say you had an order that was running and you needed to, like, there's a big red button, like at Amazon, you had the and on chord, right? If something really went wrong and everything stopped. So let's say you had that scenario, you had like 1,000 orders and you needed to tell them all to pause or stop immediately. You can send a signal to those running workflows. A signal is a temporal concept that allows you to take new information while workflow is running and handle that information. So in this case, the information would be, hey, pause all of these orders, please. And you have a signal handler in each of those workflows, that order workflow that goes, oh, okay, I just received this signal. I was doing something, but I just received this signal. Let me wait, or let me do something else because I received this signal. And so async on many levels is something that's quite easy to do. It's probably the topic of a follow-up webinar, to be honest. But yeah, the answer is an emphatic yes.
Perfect. And then we'll do the last question here. Someone wants to know if the whole saga is operating in a single workflow versus multiple workflows under a single worker.
Ah, in my case, in my example, it was a single workflow. Um, the relation, I wouldn't think about a tight relation between workers and workflows. Multiple workers can execute one workflow. In certain scenarios, like I wouldn't even think about it. That stuff sort of happens transparently to you. Um, you can run sagas across a number of workflows. I would probably recommend against it because a workflow is really where your control logic lives. So if you want a series of compensations, you probably should put that control logic in one place. An exception to that would be if you had, let's say you had a top level workflow and then you had control logic owned by other teams, for example, you might want to have child workflows owned by those teams. And so you have this kind of parent workflow that does the overall order. And then maybe the payment thing is its own workflow. That's a child workflow. That's a temporal concept. And then, so if a saga would be refund that payment, might be a child workflow, that kind of thing. So you can get this kind of hierarchy of workflows, and that can be owned by different teams and different workers then. But all of that's possible. That's, again, probably a deeper best practices conversation. But generally, I would say if you want, at its simplest, if you want compensations to happen and rollbacks to happen, it's best if you think about putting them in the one place, in the one, at least directing them from the one parent workflow, because then you have a single durable place to view how that overall business transaction is going. And we do a lot of, as a solutions architect, we do a lot of workflow design sessions with people, and we spend a lot of time helping them conceptualize how their business transactions are going to fit into workflows, and it's usually pretty natural. But we help them weigh pros and cons and that kind of thing.
Great, perfect. Thank you so much, Steve. So if you just want to go to the final slides, we can wrap up here.
Yes. Great questions, by the way. Just a lot of great questions.
Yeah, great questions. Thank you so much for all the questions. And thank you, Steve. Thank you for your time. That was awesome.
No
Thank you
worries.
so much to everyone who joined and who's been really engaged. If you liked this session, we actually do have another session coming up on June 20th about sagas. So one of our customers, Will Bank, they're going to be talking about how they have implemented sagas using Temporal. So that'll be a really great follow-up just to learn a little bit more. You can register on our website, or you can just scan the QR code there and go ahead and register now. So that's it. Thank you, everyone, so much for joining. Thank you, Steve. And yeah, we'll see y'all later.
Thank you, Megan. Bye.
All right. Bye.